Imagine for a moment, you're flying a 40-year-old military jet, sneaking into enemy airspace, and the only thing standing between you and total success, or instant death, is just a regular tablet stuck on the cockpit panel. It might sound like an exaggeration, but that's exactly what happened in May 2024 when a Ukrainian pilot pulled off a mission that forever changed how we see military innovation. What you're about to discover today isn't just about military tech, but about how human creativity can outsmart billion-dollar budgets and the world's most advanced defense systems. The MiG-29 Fulcrum was built back in the 1970s during the height of the Cold War. This Soviet fighter was made for one thing: to be fast, agile, and deadly in dogfights against targets flying high and fast. The computers on this jet were designed at a time when the internet was just a dream in university labs. Its navigation systems didn't know what GPS was, had no clue about satellite communication, and certainly weren't built to work with precision-guided weapons based on tech that didn't even exist when it was made. The MiG-29 has some unique features that make it special. It was powered by RD-33 turbofan engines, each pushing out 8,300 kilograms of thrust. Its top speed hits Mach 2.25, about 2,400 kilometers per hour. The original N019 Rubin radar can track up to 10 targets at once, but was designed to spot big strategic bombers, not to guide precision weapons against specific ground targets. Ukraine inherited around 220 MiG-29s after the Soviet Union broke up, making it one of the biggest fleets of this aircraft type in the world. Over the years, many were sold off or retired, but the ones left went through a fascinating modernization process. Ukrainian engineers developed the MiG-29MU-2 program, which included new avionics systems, updated radars, and most importantly, the ability to integrate Western weapons. Thanks to that, today Ukraine uses these jets in modern military operations where they have to carry out missions completely different from what they were originally made for. Instead of traditional air combat, they now need to perform surgical precision strikes against specific ground targets using state-of-the-art Western weapons. What many don't know is that Ukraine runs one of the most advanced MiG-29 modernization programs in the world. Since 2014, Ukrainian engineers have worked tirelessly to turn a fleet of Soviet fighters into modern, effective combat platforms. The Ukrainian company behind these upgrades developed what they call a domestic modernization kit. This program gradually replaced Russian components with Ukrainian or Western equivalents. Hydraulic systems were updated, new multi-function displays were installed in the cockpit, and most importantly, the onboard computers were completely swapped out for versions that can handle modern digital data. The cost of this modernization is impressive for its efficiency. Buying a new fighter would cost between 50 to 100 million Brazilian reais, while upgrading a MiG-29 costs about 20 to 25 million reais. That means with the budget for one new fighter, Ukraine can modernize 4 or 5 existing jets. But the real genius isn't just in upgrading the internal systems. Ukrainian engineers develop universal adapters that allow weapons from different countries to be used on the same aircraft. This means a single MiG-29 can carry French missiles, American bombs, and Israeli guidance systems, a flexibility that not all modern fighters have. The program also included improvements to protection systems. New electronic warfare gear was installed, capable of detecting and jamming enemy radars. Missile warning systems were upgraded for faster threat detection. And maybe most important, new navigation systems were integrated to allow precision flights deep into enemy territory, even without GPS. The challenge Ukrainian engineers faced was basically a translation problem, not between languages, but between totally different generations of technology. The original MiG-29 weapon systems were designed for Soviet air-to-air missiles like the R-27 and R-73. These missiles used simple analog communication protocols, basically direct electrical signals that said turn on, turn off, or fire. On the other hand, modern ASM Hammer missiles require complex digital data streams, precise GPS coordinates, inertial navigation info, weather data, and terminal guidance commands. This is where the iPad becomes revolutionary. Acting as a middleman computer, it runs custom software that can simultaneously talk to the MiG-29's old systems and the modern missiles. Imagine a translator who has to convert not just words, but entire concepts between two totally different cultures. The software on the iPad receives GPS data from the tablet itself, calculates optimal ballistic trajectories, compensates for environmental factors like wind and air density, then converts all that into commands the 1970s weapon systems can process. At the same time, it programs the ASM missiles with target coordinates, flight parameters, and detonation instructions. What makes this even more impressive is the speed. In combat, where seconds can mean life or death, this whole translation and integration process happens in real time. The pilot sees the process data on an intuitive interface on the iPad, can confirm the target, tweak parameters if needed, and fire, all within seconds. It was about 5:45 a.m. on May 26, 2024, when our Ukrainian pilot was prepping for a mission that seemed impossible. The target wasn't just some regular military depot or a peripheral facility. It was none other than a Russian Federal Security Service installation in Belgorod on Russian soil. The Federal Security Service isn't just an office building. It's the direct successor of the feared Soviet KGB and stands as a key pillar of Putin's security apparatus. Attacking this site meant penetrating not only enemy airspace, but also the symbolic heart of Russian intelligence. The aircraft carried 2 French ASM Hammer missiles, each weighing 250 kilos. But calling these devices simple projectiles would be unfair. The ASM Hammer is a masterpiece of modern military engineering, available in 3 guidance versions: INS/GPS with inertial and satellite navigation, infrared guidance for heat-emitting targets, and laser terminal guidance for moving targets. Let's get a closer look at this fascinating tech. The ASM is 3 meters long and weighs 330 kilos fully loaded. What makes it special isn't just its precision, but its versatility. It can be fitted with different explosive warheads from 125 kilos up to 1,000 kilos, depending on the mission. Its range is impressive, over 60 kilometers when dropped from high altitude, and still maintains 15 kilometers range when launched from low flight. The real magic happens in the propulsion system. At the back of the missile, a solid-fuel rocket motor ignites after launch, speeding the projectile to near supersonic speeds. 4 fixed wings provide stability during flight, while tiny directional fins make hundreds of corrections per second to ensure surgical precision. To truly understand why this mission was so groundbreaking, we need to know how modern air defense systems work, especially the feared S-400. The S-400 Triumph is considered one of the most advanced air defense systems in the world. It operates through a complex network of radars and missiles that work together like a deadly electronic orchestra. The main system includes long-range search radar, tracking radar, guidance radar, and multiple types of interceptor missiles. The search radar can detect targets up to 600 kilometers away, but here's the catch. This only works if the target is within the radar's line of sight. The Earth's curvature creates what's called a shadow zone, an area where low-flying targets become completely invisible. Let's do a simple calculation to understand better. A radar placed 10 meters high can see a target flying at 100 meters altitude up to roughly 40 kilometers away. But if that same target flies at just 50 meters, the radar horizon shortens to about 25 kilometers. Our pilot was exploiting exactly that physical limit. The S-400 has different missile types for different threats. The 40N-6 is designed for long-range targets like strategic bombers and refueling aircraft. The 48N-6 is optimized for fighters and cruise missiles. The 9M96 targets smaller, more agile threats. But all these missiles share one trait. They assume they'll have enough time to detect, track, and intercept the target. At 6:22 a.m., the pilot reached the mission's critical point. He yanked the stick hard, and the MiG-29 responded instantly, the nose climbing at a 45-degree angle. G-forces slammed the pilot into his seat as the altimeter spun wildly. 1,000 meters, 2,000, 3,000. Suddenly, the radar warning system in the cockpit exploded in an electronic cacophony. Every air defense system in Western Russia had just detected an enemy fighter climbing straight into their engagement zone. The closest S-400 system, located southeast of Belgorod, started painting the MiG with its fire control radar. But the pilot had a crucial advantage: surprise. Russian defense procedures were built around conventional attack profiles. They never expected Ukraine to try something this bold. At 5,000 meters altitude, the pilot hit the launch point. The iPad showed the optimal firing parameters. 2 heavy impacts shook the fuselage as the ASM missiles were released from the wings. Immediately, he pulled off a maneuver that would have impressed even the pioneers of combat aviation. The MiG-29 made a radical turn in the sky, trading altitude for speed as it dove back to the safety of low flight. The Russian reaction was quick but ineffective. 2 interceptor missiles were launched from their platforms, racing to catch the MiG-29. But the jet was already back down at treetop level, doing evasive maneuvers while heading home. The interceptors, designed to take down high-altitude bombers, couldn't track a target close to the ground. They harmlessly passed overhead, their proximity sensors finding nothing but empty sky. Here's the key point. The S-400 had a fatal vulnerability. Despite all its sophistication, the system needed about 10 seconds from detection to engagement when dealing with low-altitude targets that appeared suddenly. Against a fighter pulling a ballistic launch maneuver, that was catastrophically slow. In less than 2 minutes, the missiles hit their target. The first ASM hammer pierced the roof of the Federal Security Service headquarters. The fuse, programmed for a 25-millisecond delay, counted down precisely as the warhead plunged through the building's upper structure. After detonation, its 87 kilos of explosives turned from solid to gas in microseconds. The shockwave expanded at 8,000 meters per second, creating overpressures above 200 pounds per square inch, enough to neutralize anyone inside the building. The explosion inside the enclosed structure created a phenomenon called reflected overpressure. The shockwave bounced off surviving walls and floors, doubling and tripling its destructive power. The windows didn't just shatter, they exploded outward in a shower of glass found embedded in buildings 300 meters away. According to reports, the attack targeted a temporary crossing built where a previously destroyed bridge once stood. The jet used 2 American GBU-62 bombs upgraded with JDAMER kits, technology that allows GPS-guided precision and extended range. The importance of this strike goes way beyond physical destruction. Attacks inside Russian territory carry huge symbolic weight. They directly challenge the Russian narrative that the special military operation is a distant, professional conflict with no cost to ordinary Russians. The deepest implication of this operation goes beyond technology. It marks a fundamental shift in modern military doctrine. For decades, air supremacy was defined by who had most advanced fighters, the most sophisticated missiles, and the priciest defense systems. This mission turned that logic upside down. It showed that small nations with limited resources but high creativity can develop tactical solutions that neutralize traditional tech advantages. This is what military experts call asymmetric innovation, using unconventional methods to beat theoretically superior foes. The concept isn't new in military history. During World War II, Finland used unconventional tactics to resist the Soviet invasion. In the Vietnam War, guerrilla forces neutralized American technological superiority through adaptability and local knowledge. But what we see in Ukraine is a high-tech version of that same philosophy. The iPad MiG-29 integration represents what military analysts call the democratization of precision warfare. Previously, only countries with billion-dollar defense budgets could develop satellite-guided weapon systems. Now, any air force with enough creativity can adapt commercial gear to build similar capabilities. This approach has huge geopolitical implications. Smaller countries no longer need to spend decades and billions developing weapons systems from scratch. They can speed up development by creatively integrating existing tech. It's a change forcing military superpowers to rethink their deterrence and defense strategies. Ukrainian innovation hasn't gone unnoticed by the global defense industry. Companies like Lockheed Martin, BAE Systems, and Thales are already studying how to integrate similar solutions into their own products. The concept of rapid modernization is becoming a focal point in new weapons development. At the same time, this approach is pushing defense manufacturers to rethink their design philosophies. Systems like the S-400 were built assuming predictable, conventional threats. Now they have to consider adversaries that might show up with totally unexpected solutions. The industry is responding by developing more adaptive and smarter defense systems. Artificial intelligence algorithms are being integrated to detect unconventional attack patterns. Radar systems are being modified to better spot sudden launch maneuvers. Interceptor missiles are being redesigned to react faster to emerging threats. So we can conclude that the future of military defense no longer belongs just to superpowers with the biggest budgets. It belongs to whoever can innovate faster, adapt better, and think outside the conventional box. Now tell me in the comments, in your opinion, what's more important in modern defense? Having the most expensive and advanced equipment, or having the creativity to use what you've got in an innovative way? I want to know what you think about this. If you enjoyed this story, don't forget to subscribe to the channel and share this video with that person who loves fascinating military stories.